Hey, this is the solution for 15A. Just going to copy out the question here, and this is on page 132. So this one has 1/3 times 3x plus 12. So it's a little bit trickier looking because we have a monomial that we're multiplying into a polynomial here. So we have to multiply the 1/3 in to the 3x and the 12, but we've got a fraction, which makes it feel a little bit harder, but it's going to work the same way. So for instance, if I had, say, 4, so if I had something like, for instance, 4 times 3x plus 12, I would multiply 4 times 3x and say that that was 12x. And I would multiply 4 times 12 and say plus 48. So that's the same strategy as what we're going to do here, but we just have to deal with fractions. So when I'm multiplying this first step, so here, the 1/3 times the 3x, I'm going to write that off to the side. So if I was doing, 1/3 times 3, that's like 3 over 1. So I would get 3 over 3, which reduces to 1. So when I multiply here, I would be doing 1/3 times 3x, and 1/3 times 3 is just 1, so it's just 1x. And then the other piece here, I would be multiplying the 1/3 times 12, so I might do that off to the side. I don't want to keep that in my work for the question because it could be could get a bit too messy if I did it in there. But I know I'm going to have to multiply 1/3 times 12, so that would be like 12 over 1. So then I get 12 over 3, and that equals to 4. So now I know when I'm doing this second multiplication, the 1/3 times 12, my answer is positive 4. So then that's my answer for that question. So I think the key here is just to kind of show your work if you need to, when you're doing the multiplication of fractions, off to the side so it doesn't get like mixed up and bogged down in the middle of your question.